Hello students, today we'll be looking at Introduction to Organic Chemistry. What is organic chemistry? We say that organic chemistry is a branch of chemistry that deals with the study of carbon. That is organic chemistry. How we say that? We quickly look at the term hydrocarbon. Hydrocarbon. Now, from the word hydrocarbon, that is hydrogen and carbon. So hydrocarbon is a compound that contains carbon and hydrogen as its main element or as its major element. I come again. Hydrocarbon is a compound that contains carbon and hydrogen as its major element. Now let's quickly look at the classification of hydrocarbon. Before I talk on the classification of hydrocarbon, I would like to tell you the sources of what? Of hydrocarbon. Okay, the sources of hydrocarbons are, we have number one, petroleum or gas. These are the sources of hydrocarbon. If you are asked sources of hydrocarbon, you say petroleum or crude oil, then the second one is coal and the natural gas. Now, let's quickly look at the classification of hydrocarbon. So, classification of hydrocarbon. Now, hydrocarbon can be classified into two. So, one, we have the aromatic. Number two, we have the aliphatic hydrocarbon. These are the two major classifications of hydrocarbon, aromatic and aliphatic. I picked the first one, number one, which is what? Aromatic. Aromatic hydrocarbon. We say that aromatic hydrocarbons are a group of hydrocarbons that have a distinctive smell. Yes, they have a characteristic smell from the word aroma. Now, examples of aromatic hydrocarbon, the most common example of the aromatic hydrocarbon is we have benzene. Yes, this is the most common one. But other examples, let me just list them. Other examples are, then another one, we can have naphthalene. Then we can have another example, we can have toluene. Then we can also have phenol. All these are other examples of aromatic hydrocarbon. You have benzene, you have naphthalene, you have toluene, you have phenol. These are examples of aromatic hydrocarbon. Then number two, which is this particular one, we have the aliphatic hydrocarbon. Now, these aliphatic hydrocarbons are either straight chain hydrocarbon, that is linear, or they are branch chain or even cyclic. That is the aliphatic hydrocarbon. They are either straight chain or branch chain or even cyclic, in form of cycle. Now, this aliphatic hydrocarbon is further classified into two, which is where we have the cyclic and the acyclic. Cyclic and the acyclic. Then the cyclic, from the word cycle. Then the cyclic are the ones that have closed chain ring. For example, you have carbon like this, carbon like this, carbon like this, carbon like this, carbon just like this. They have a closed carbon chain. Yes, they are all close together. Then the one that is acyclic, that means they are the linear, they are the straight chain. This one is the cyclic, while this one is the closed chain. While this one they are the straight chain hydrocarbon. Now let's give some examples of that. Now for cyclic, we have compound like cyclopropane. Cyclopropane, we have it like carbon, we have this, 2C. I'm writing H2C because the bond is between carbon carbon, not hydrogen. Carbon to carbon bond, so not hydrogen, so it is like this. Then this one is cyclopropane, cyclopropane. Then we also have compound like this. Here we have 2, that is 1, 2, 3, 4, 5, 6. This one is going to give you 2 plus 6, 8, 4. This one is going to give you what? Cyclohexane. Because they are having close ring, they are all close with carbon. They are all close with carbon. We call it cyclo. Cyclo. This one becomes cyclo. How many carbon? 1, 2, 3, 4, 5, 6. Cyclohexane. Because 6 is actually what? Hexane. So these are examples of cyclic, even cyclobutane, cyclopentane, and all the cyclo, they fall under this cyclic, of which they are aliphatic hydrocarbon. Then for this acyclic, that's where we have a straight chain like methane, like ethane, propane, butane, pentane, all these hydrocarbons. So I will give more of that soon. So having done this now, we move on. Acyclic, they are further classified into alkane, and alkyne. Okay. Now, acyclic, which are the straight hydrocarbon, are further classified into acyclic, alkane, and alkyne. So let's talk on. So now let's quickly pick for. We have alkane, then we have alkene, then we have alkyne. Alkane are saturated hydrocarbon. I'm going to explain that. Alkene, they are unsaturated hydrocarbon. While alkyne, they are unsaturated what? Hydrocarbon. Now, let's look at this first one. When we say alkane, in bracket, they are what? Saturated. So, alkane are saturated hydrocarbon. Alkene are unsaturated hydrocarbon. While alkyne are unsaturated hydrocarbon. What are saturated hydrocarbon? Saturated hydrocarbon are hydrocarbon that contain a single bond in between their carbon atoms. I come again. Saturated hydrocarbon are hydrocarbon that contain a single bond in between their carbon atom. Let me explain. So, for example, we have ethane. We have carbon, we have hydrogen, we have hydrogen. Okay, let me give another example. So another example, let me use butane. This is butane, and the formula is what? C4H10. C4H10. So we have carbon 1, carbon 2, carbon 3, carbon 4, hydrogen, we have hydrogen. So you can see there is one carbon in between there is one bond in between the carbon atoms. One bond. So since we have a single bond in between the carbon atom, so that compound is what is a saturated hydrocarbon, which is what an alkane. So alkane, they are saturated. Alkane are saturated because they have a single bond in between their carbon atom. Then the second one is unsaturated, which is alkene. Alkene, that is unsaturated. Unsaturated hydrocarbon are hydrocarbons that have a double bond in between their carbon atom. While alkyne, they are unsaturated hydrocarbons that have a triple bond in between their carbon atom. Alkyne are unsaturated hydrocarbons that have a triple bond in between their carbon atom. So this one, we are going to demonstrate this one. We are going to have something like this. For example, now let's have, okay, this is 2. This one is going to be 1, 2, 3. So this triple bond signifies that this is an alkyne. This is an alkyne. Do you understand that? Now, for alkene, this double bond signifies that this is an alkene. 1, 2, this is double bond. While for alkane, you have only one bond individual. Do you understand that? So let's now look at the have on the board. We have examples of hydrocarbon. Now we have N, where N is 1, 2, 3, 4, 5, 6 to 10. Then we have examples of hydrocarbon. These are the examples of hydrocarbon, the first 10. This is just the first 10. And students, please try your best to memorize these first 10 and do not scatter them, just the way you were told not to scatter the first 20 elements. You say hydrogen, helium, lithium, barium, boron. Don't scatter them till you get to 20. Arrange them in the order of increasing atomic number. So you also need to arrange this in this order. You have methane. Number first one is methane. Then you have ethane, propane, butane, pentane, hexane, heptane, octane, nonane, dentate. That is 10. Then that is how it is. Now, these alkane, they are the saturated hydrocarbon. I have said that. So we said they are the saturated hydrocarbon. You already know what saturated hydrocarbon is. We have done that they have a single bond in between their carbon atom. Then why this one is what? Unsaturated. The last one is still what? Unsaturated. Yes, unsaturated. This one has a double bond, which is alkane has double bond, while alkane has triple bond in between their carbon atom. Now, if you look very well, you can see a general molecular formula for the alkanes. All the alkanes here, they have a general molecular formula or CN. CN, I've written before. CN is written here. We have CN H2N plus 2 for alkane. So this formula is their general molecular formula. Alkane has this general molecular formula. Then you will use this general molecular formula to derive each of the compounds, each of the member. Alkane, you can see alkane is the family here. This is a homologous series anyway. Alkane is the family here. This is alkane. Then all this methane, ethane, propane, butane, pentane, all of them, they belong to that group of alkane. Do you understand? They all belong to the group of alkane. That is why you are seeing this A, N, E. If you check all these ones, they are having the same A, N, E. They are all alkane. That's why you have methane, ethane, propane, butane, pentane, hexane, and all of that. Then looking at this second one as well, you see that we have methane as number 1 here, but number 1 here we don't have methane. We don't have methane here for number 1, but we start from number 2, which is what? Ethane, because we have ENE here as well. Alkene, ENE. So we now have ethene, propene, butene, pentene, hexane, heptene, octane, nonane, and so on and so forth. So this is all these ones. They are examples of what? Of alkene. The examples of alkene are these ones you see here. They are alkene because they are unsaturated, which have a double bond. For the last one we have here, we have unsaturated, which is alkyne. And sorry, before I go there, their general formula is what? CN for alkene. General formula for alkene is what? CnH2n. That is their general molecular formula for their own homologous series. We move on to the last one, which is alkyne. Alkyne have triple bond, and they have general molecular formula of CnH2n minus what? 2. Then we still do not have methane, because here, we have methane here, but we didn't have methane here. We do not still have methane here. But here we have ethane, here, which is number 2. Here we have ethene. Here we have ethane. Yes. So let me just number this. We have 1, no 1, then we have 2, C10. So this is just 2. Okay, now let's quickly derive their formula. It's very simple. It's very simple. For alkane, this is how you derive your formula. Now let's derive for methane. Then for methane, this particular one, this is methane. Then we said that the general molecular formula is CnH2n plus 1 plus 2. Where n for methane, n is what? 1. For alkene here, for this alkene, n starts from 2. This one, n stands from, let me just remove this one, let me remove this one so that you don't get confused. This is n. So n starts from 2, n starts from 2. Yes, because we don't have n1 for these ones. So, but let's come back to this place, please. For CnH2n, let's take for this is alkane. Alkane have 1. 1 is methane. So with anywhere you see n is 1. Anywhere you see n, 1. You now have C times 1, H2 times 1 plus 2. Because n is 1, we are putting 1, 1. So C times 1 is the same thing as C. 2 times 1 is 2 plus 2, 4. So the formula for methane is what? Is CH4. The formula for methane is what? CH4. Now let's jump to, okay, well, let me do 2. For number 2, where n is equal to what? 2. N is now what? 2. So still go back to this guy, general molecular formula. Anywhere you see n, substitute. Anywhere you see n, substitute 2 for n. Then you now have C times 2, H2 times 2 plus 2. C times 2 is what? C2. 2 times H, 2 times 2 is what? 4 plus 2, 6. C2H6. This is the formula for ethane. Do you understand now? I've done 2, so you should do the other ones and tell me your answer in the comment section. So, but for this number 3 now, we are going to have C3, N is 3, C3, 2 times 3 is what? 6. It's going to be C3, H8, because 2 times 3 is 6 plus this 2. 2 times 3 is 6 plus 2. It's going to be C3, H8. So for this one, for butane, which is number 4, where N is 4, we are going to have C4, H, 2 times 4, 8 plus 2, 10. We are going to have C4, H10. So it's very simple. That's how you do for the other one. Then for this second one, which is alkane. So let me quickly solve for that one. Then now let me manage this place. We have CnH2n, where n is what? 2. We are not using 1, where n is 2. So when we substitute n is 2 here, we are going to have C times 2, H 2 times 2. We are going to have C2, H4. So the simplest member is 18. And the formula for 18, the simplest member of alkene is 18. That is the simplest. So the formula is C2H4. For propene, where n is 3 for propene, that's why I say you should not scatter it. Methane, ethane, propane. That same thing is propene for double bond. Propane is for saturated. Propane is for unsaturated, which is alkene. So propene, where n is 3, just write C3, H 2 times 3 because n is 3. We have 2n. 2 times 3, 2n. N is 3. So C3, H 2 times 3 is what? 6. Your formula becomes C2H6. That is for propene. And if you even check now, you see that 18 is what? C2H6. 18. Sorry. Ethane is C2H6. That is ethane. For ethane, C2H4, they are just reducing by what? By 2. Ethane is 6. This one is going to be what? This one is what? 4. Butane is C4H10. Butane is C4H10. This is butane, C4H10. Butane is going to be C4H8 because we have C4 H8 because N is 4. N is 4. N is 4. So see the formula CN, that is C4, 2 times N. Then 2 times 4, that is 8. Then for the last one, which is alkyne, which is the triple bond, alkyne begins from there. Let's substitute. Where N is 2, let's substitute for this formula. So we now have C times 2, H2 times 2 minus 2. C2, H2 times 2 is what? 4 minus 2. We now have C2, H2. This is the formula for alkyne. Alkyne is what? C2, H2. You can see 18. Look at 18. We have C2H6. 18. We have C2H4. Alkyne. We have C2H2. So they are just reducing with what? 2, 2, 2. So for this also you can substitute for propine. Propine. What is our propine? N is what? 3. You have C3. H2 times 3, 6 minus 2, 4. You have C3, H4. Let's put it. C3, H4. I said C3, H4. So where N is what? 3. We have C times 3, H2 times 3 minus 2. Then we have C3. 2 times 3 is what? 6. 6 minus 2, 4. So that is how we do for all of these ones. So in our next class, we will be talking about the homologous series, functional group, and acute group. That is the next stage of this introduction to organic chemistry. So in our next class, we'll be talking on the homologous series. Then we'll be talking about the functional group and acute group. From there, we'll go into naming of organic compound. Thank you and remain blessed. Bye.